Okay, so let's get started. We're going to be taking a look in this training module at reviewing some calibration file and data log paired together in order to evaluate how our closed loop boost control system is functioning when we're looking at data from a data log. So this is going to be primarily how you're going to be calibrating and tuning your closed loop boost control system, looking at logged data, and then evaluating what's going on within the control system. So we're going to take a look at a couple different examples here, just getting familiar with some strategies and some layouts, doing our closed loop boost control. What we're going to do here is open up a paired calibration file and a data log together. So they're going to be matching. We're going to take a look at the control strategy in the calibration file and then look at the data log and see how the system is performing and what things we need to know and pay attention to. All right, let's take a look here at opening up a sample calibration file first. We're going to go to File. Let's go to Open. We're going to go to Desktop, and we're going to go to our G5 course packet. And then here, we're going to go to our sample tune files. That's our calibration files. We're going to take a look here, closed loop boost example 2. So that's example 1 and 2. And then we also have EVO 9 big turbo. That's going to be our third example we take a look at here. So closed loop boost example 1, this should be from a, I believe it's a 2007 or 8 Subaru STI with a plug and play G4X box. If it doesn't matter if it's G4X or G5, the system works the same. So here is the calibration file. We're going to go over here in just a second. And then we're going to take a look here. Let's go to logging. Let's go here to open log file. We're going to go back under the desktop, go into our G5 course packet, and then go here to our sample log files. And then we're going to take a look here at closed loop boost example. We're going to go ahead and open up this example file. So this is the data log that's paired to this calibration file. So we can see here, if we go all over to the right, we're going to find in our time plot window, we have, looks like 2 different boost pools, and we can actually go in here, click on this area. Again, this is RPM. We can see here in that light blue, and then zoom up, and this will go ahead and zoom us into taking a look at this. Now, one thing I want to note, these colors are kind of crummy to take a look at here with the black background. Let me go here to properties, and let's go here and click on the dark blue colors. Let's go to edit. Let's change them to a brighter color like yellow so we can see this a little bit easier, because again, it's kind of a drab color and it does not stand out very well here. So let's go to edit. Let's go here to yellow, and let's take a look here. Boost status. Let's just change our color up there. Let's change that to something brighter. We don't have a whole lot of choices. Do we have a pinkish color? Does not look like we have a pinkish color. All right, we'll leave that on white. That should be better than at least what we had there. Let's click OK. Now we can see things a little bit better. So we're focused in here on the data log to see how the system is performing. Let's talk about what this particular file was set up with and the control strategy we have here. Then we'll take a look at our data log to see how it's actually performing. Okay, so let's go over here to the left in our screen. We're going to find that obviously the system here is in closed loop boost control. We're using our boost source for map. This was a single wastegate with a 3-port boost control solenoid for reference. Was assigned here for aux 5, and it's a low side output, 30 Hertz. It's pretty normal. We have our RPM activation, 1500 RPM and above, 105 kPa map pressure and above. The active tables was set to interpolate between. Now, this is important because this car was tuned using the flex fuel tuning feature. So it's a modeled multi-fuel option for tuning. And because we're basing everything around our ethanol content sensor, we're going to find that we have 2 different boost targets we're working with here. We have our boost target table 1. That's used for petrol fuel for the boost target table 2 that's used for ethanol fuel. So we have these 2 different tables, and one is for pump gas, one is for ethanol content. And we actually blend between these 2 tables. So the interpolate between option, we'll go ahead and assume that you're using the table down here, boost table ratio table. This is going to look at your multi-fuel blend percent, which is essentially your ethanol content, 0 to 100%, so 0% ethanol to 100% ethanol. Now the values in the table here, 0 to 10, I've assigned this so that it has a value of 0. 0 in the table means that we're using 100% of our boost target. So between 0 to 10% ethanol blend in our fuel system, we're all on boost target table 1. When we're going to be 70% ethanol and higher here, scroll over, 70% ethanol and higher, we have a value of 100. That means that we're using 100% of our target from our target table 2. So 70% ethanol and higher, I'm on my highest boost target. 0 to 10% ethanol, we're on our pump gas boost target. And then between these two, so as our ethanol content increases, it'll have a weighting factor somewhere between the two targets based on all the ethanol content. So we can see how that works. It's pretty simple. Now, we have our boost PID setup here. We have a stage 2-3 option. We always want to use this. This allows us a proportional derivative for spool up and then proportional integral to control the target. 20% duty cycle on our stage 1. That's used to try to spool the turbo up a little bit quicker. Stage 2 is turning on here at 100 kPa from the target. So it's starting to arm and work with our proportional derivative feedback. 100 kPa is definitely a little bit steep here, but this was a relatively laggy turbo, and I was trying to get it to spool up quick and trying to allow the feedback control system to work, so we'll see that in the data log. Stage 3, we start to turn on for the control at 50 kPa to the target. That worked for this car, and then the hysteresis here, 10 to 20 kPa is pretty normal. Stage 3 doesn't turn on for 0.5 seconds, that's also fine. The min-max clamp, 0 to 90% duty cycle, that's normal, and then the proportional integral derivative gains, we can see we have a relatively small value here. So 0.3, 0.5, 0.6. And then our integral clamp was clamped at 1.5% duty cycle. That's the min and max that it's able to feedback in the integral control for working with this. So the PID setup, again, was unique to the vehicle. We can take a look here. We have our wastegate feed forward duty cycle table 1 and 2. These two tables should be identical to each other because they're based on boost target versus engine speed. Regardless of whatever our boost target is changing to relative to ethanol content, we'll find that we want to have the same duty cycle here for its starting point for the feed forward feedback. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.